I took my car back to the dealer, said this thing is almost new. I took my car back to the dealer, said this thing is almost new. Just take a look at that fender, it's almost rusted through. He said, you got redox, baby, eating at your car. He said, you got redox, baby, eating at your car. You better do something quick before that process goes too far.
So we're going to talk a little bit about redox, but I find it interesting. When you take a look at chemical reactions in any freshman, or I should say high school chemistry book, the first book these high school kids get in chemistry lists 4 kinds of reactions in the chapter. Sometimes they list 5, but they say synthesis or composition. In fact, that's what we're going to be looking at today. Composition, some books call it combination, some books call it synthesis, just to confuse the kids. Then they talk about decomposition, single replacement, and double replacement. Those are great terms. Then they graduate with any kind of luck, they go off to college, and they never use those terms again. Because in college, they rap with them. They talk about redox, acid-base, and precipitate. They don't use those terms ever again. I didn't know if you knew that. Many teachers don't actually realize that. These are nice terms: combination, synthesis, decomposition, single replacement, double replacement, but they're never used again in college usually. In fact, combination and decomposition are almost always a redox reaction, as are single replacements. So if you think about this, the one that we're going to do, we're going to take a lovely chunk of zinc right here. This is a big piece of zinc metal, so I can touch that with my hands, not a problem. Here is some zinc powder, which I'm not going to touch with my hands. Here's a lovely chunk of sulfur. That's nice. Here's some flour of sulfur. Both of these have an oxidation state of 0, they're elements. And we're going to produce or yield some zinc sulfide. And here we have an oxidation state of 2+ and 2-. So that's our goal for this particular experiment, to do this redox reaction or this synthesis reaction. We will need to use the powder forms because we want these to have intimate contact. All right? And so I'm going to take a scoop of zinc, and I'm going to take a scoop of sulfur, okay? And I'm simply going to mix these up. And at this point, we're not going to get much of a chemical reaction. These are both solids. They're at room temperature. They really need some activation energy. They need to be heated up in order to react. Okay? So we have a mixture, and it's not even really that homogeneous. I can still see lumps of each present. Eventually, I might be able to get it sort of homogeneous. And I could separate this. Because it's a mixture, it's easily separated by a physical means. I could pour it in water. In this case, because it's flour of sulfur, the sulfur, a lot of it would float, the zinc would settle to the bottom, and you could separate the two. But once we form the compound, zinc sulfide, then it won't be easily separated by physical means. So I've pre-measured out a stoichiometric amount that I want to use in my particular reaction here. I'm going to put it in this porcelain cup here, and we're going to react it. We're going to take the flour of sulfur, or sulfur, plus zinc to yield, and that's what the arrow means, yield or produce a product, something completely different. Turns out electrons will be transferred. You saw that on this card. We go from an oxidation state of 0 in both cases to 2 and -2. Electrons go from the zinc to the sulfur, and that's what helps to form the bond. Again, the electrons go from the zinc to the sulfur. Zinc is oxidized, sulfur is reduced. We form this compound, zinc sulfide. Because the electrons are transferred, we form a bond. So let's go ahead and do that. going to put in the mixture. Now, I have to heat that up to get it started. So to do that, I'm going to take a piece of magnesium and use that as a fuse so that I can go away quickly. So let me bury that in there. Now keep in mind we have trillions and trillions of atoms of zinc, trillions and trillions of atoms of sulfur in the stoichiometric ratio. We're going to ignite that, and then I'm going to disappear. And you can watch this, and we might even be able to see it in slow motion afterwards at some point in time. They may be able to do it in slow motion. Can we get the lights down a little bit? I'm going to leave now. Whoa! Now you heard the vent go on, and it's a good idea to do this in the hood, or this one you might even be able to take outside and do, depending upon your situation. I would not do anything unless it was an incredibly small amount in my classroom. Let's see if we can't focus in on the contents there. Okay, I'll see if I can't bring it from behind here. And we can see what the products look like. So we yield or produce this zinc sulfide. Something, as Monty Python would say, completely different. So there we have what's called a synthesis reaction, or perhaps a better term would be a redox chemical reaction, which was also highly exothermic. Well, by the way, in order to get it going, you had to put that heat in. But once it started, it released enough energy to keep itself going, in fact, make itself go rather rapidly. But that's the story for another chapter.